Okay.
All good?
Yeah.
Cool. So I was planning to do a quick go through this first part, and I'll now have to go to do it even more quicker because I don't have time. But conscious on trying to make this a little bit more hands-on. I'll change the way that I was going to do it. I just plan to just go through this because it should be a quick overview about auto-scaling and load balancer, Route 53, and just show certificates. Because the most interesting part will be the next one, Docker, and we will get back to load balancer and auto-scaling groups when we on the next class about when we look into ECS, which is the container management service on AWS. So let's go quickly through this content here, and then instead of just showing you guys on static things on how the auto-scaling group and load balancer are, we just go through the console and try to do it together. We've built from scratch our infrastructure, and then we fire up some EC2 instance, and we were able to communicate and go back to the internet, access the instance running on public subnets, and then instance running on private subnets. We were able to download things from the internet, but not being public accessible. And at this stage, you guys kind of start putting everything together from this foundation part on the AWS. And then now we'll move a little bit more to how to plan to run a workload on AWS. And for the next class, if for the next part will be how your application itself needs to be prepared on a containerized way or something like that, and then how you run your containers on AWS. That's the path that we are moving to. So we've mentioned the first class on the AWS 101 a little bit about path first schedule. Hopefully everyone still remembers on that. It's pretty much path instance. It's that instance that you need to you have your applications installed, your dependencies. You can only scale up. So for example, you can shut down, put more memory, more CPU, and whatever you can until you reach a limit that you can't grow anymore. And that's what we call scale up. And then you need to, if you need to, that service that you are running on that instance still needs to be able to host more customers, for example. You need to have more instance serving that traffic to other people. So that's what we call scale. Sorry, I forgot the word. Horizontally scale. So you create more instance instead of just getting one instance and putting more and more and more resource into that one. So that's what it comes, the analogy of the path first schedule. If you lose your path instance, it normally will take you some time to rebuild, maybe run your scripts again to get that instance running. Whereas if it's a kettle, it will probably be running behind an auto-scaling group, which is something that will be starting the instance again automatically for you and doing any pre-configuration required to get your application up and running. Those kettle instances are normally elastic as well. So you have policies that will create more instances or delete instances that are not being used. So you can also save money with that. So on AWS, it's called the auto-scaling group, or ASG, or how we call it. It's essentially the service that does that kettle management of instance. So it's a group of instances that you can have the policies that will grow or will shrink as per your requirements. The ASG essentially has three components. The group itself, where it's your group of instances, and the group has three parameters that you need to set, which is the minimum, the maximum, and the desired capacity. As per this graphic here, you can see that will be an auto-scaling group. Your minimum size is how many instances you need to be running for your auto-scaling group. So for example, let's say 1. So the auto-scaling group will try to always make at least 1 instance running, which means, for example, if you have 3 instances running and 2 of them crashes, somehow something happened on your application, sorry, that's all based on health check. So when you create your auto-scaling group, you configure a health check that will the AWS service itself will keep checking that health check. For example, it could be on a web application, something like, for example, your website / health, just to make sure that your application is reachable and responding. So the AWS group will keep looking into that health check endpoint, and then if it stops replying, it will send a message to the group, and it will say like, oh look, I lost one of my instances, so I need to create another one. So the minimum will say we'll try to always keep at least that amount of instances running. Then you have your desired capacity, which is how much do you want to run at any point in time, for example, and the maximum one, which will be for how many instances do you want to increase if you want to, if you have, for example, elastic policy that I'll mention shortly. So for example, if a group of minimum 1, maximum 5, and desired 3, if everything is fine, your group will keep 3 instances running. If you start getting more customers on your website and you have scaling policies configured, your auto-scaling group will create more instances to be able to handle those new customers that are coming. Up to 5 instances, won't grow more than that. But once it reaches 5, we'll stop creating new instances. And then once you don't have more traffic, your policy reaches the threshold that you define it to go back. It will go back to 3, and will always keep on 3. If your application for some reason fails and your instance crash, you lose one of those, your auto-scaling group will always try to keep at least 1 running. Some other things that can happen sometimes is that the availability zone is under heavy load, and then AWS starts blocking new instance to be created. So the ASG will at least keep 1 instance or your minimum of instance running. Sometimes it happens that the ASG can't create more instance for any numbers of reasons. Apart from the group, we have the configuration template, which is when you're creating the exercise that you guys did for creating EC2 instance. There's a series of parameters that you need to choose when you run that CLI command. For example, what EMI, which is what image are you going to use, what VPC, what subnet is going to run, what type of the instance is, if it's a small, micro, medium size, EBS volumes, security groups, all those settings, it's on the configuration templates that you set. And the scaling options is how do you want to scale your group. For example, if you have your web application running, and if you reach over 70% of the memory usage, you want to start a new instance and start and to be able to handle more traffic coming up. So this could be one example of scaling up your instance. To be able to do the scale up and down, you can rely on another AWS service called CloudWatch. We'll go more through CloudWatch. It's a very simple and at the same time very complex feature service, and we'll go more into details into that. But essentially, you can have metrics from the services running on AWS, so to check how much CPU is being used, memory, even custom metrics. For example, if your application keeps track of how many users are connected at one point in time, your CloudWatch could be looking into that statistic coming from your application, and then you can create an auto-scaling based on that. For example, if it goes over 100 users, create 1 more instance to be able to handle 20 more users, and then it keeps creating. When creating auto-scaling policy, one feature that you need, one option that you need to choose is after scaling, how much time do you wanna cool down until you do another scale up? Because let's say your instance goes over 70% of capacity. I will say capacity, it could be anything. It goes over 70%, and you create a new instance. If you don't wait a little bit and see if you will need more, you could just keep creating new and new and new instance. So that's an exercise that's always hard to get the exactly thing that you need, how your scaling policy should look like. But essentially, we like to say that on the first few months, maybe 2 or 3 months that you set up your auto-scaling groups and your application on the cloud, you spend more money than you should. And then once you start having more statistics and logging and monitoring, you have a better picture of how much traffic you need, how much resource you need, and then you can plan better your scaling policies and your sizing of your instance. That's normally what happens. The first few months in the cloud, you spend more money, and then with time, you are able to fit more properly for your needs. Let's see what's next here. There's no cost for the service itself. You only pay for what your EC2 instance are running. So if you have just one instance, you pay for that. You have more. If you put a auto-scaling policy and you put 150 maximum instance, you probably have a bigger view if you have issues and you keep scaling. So that's essentially how the auto-scaling group works. I want to show you guys how to create your auto-scaling group. We'll see if we have time and if it works as well. It's not a silver bullet. It doesn't solve all the problems. It's mainly used with stateless applications where it's easy to handle. For example, because in e-commerce example, if you have 3 instances serving traffic for your users, what happens if your user come through one instance and then after a few minutes or of some time, it starts replying from another instance? How they keep track of caching and sessions and those kind of things? It's hard. It's not impossible to have stateful applications. Stateful applications, for example, it's a job that is running on instance 1 behind an auto-scaling group, and for some reason, you will delete that instance and will create another one. You need to pass whatever data you created on that instance to another one. So it's possible, still possible to have stateful. It's just more tricky, but it's often the best approach when dealing with containers. Does auto-scaling policies helps in all cases? For example, still keeping the e-commerce example, would auto-scaling policies help for all the case? For example, you have 5 instances, your e-commerce, it's holding 500 users in one point, and then suddenly you create a new promotion and you get 1,000 more users coming to your website. Will that work? Anyone wants to give any ideas on that? No? It's not going to work. Your website's going to crash because it's not something instant, right? Even if you have your 500 users, they are all working across your instance, and then on 1,000 more users come up, your servers won't hold up, and your auto-scaling policies will trigger and will create more instances, but it will take time until your new instance trigger, until your auto-scaling policies triggers and your instance come up, do the pre-configuration required, and be able to start serving the new customers, the new traffic that come to your website. So you will have a downtime if that happens. So the scaling options, that they can be automatic based on traffic and metrics, but they can also be scheduled. So if you know that you are going to release a promotion on your system, or you know that you have a surge of users coming into your system, you have to plan for that. Or you know that during the day you have more users accessing your system than overnight or on the weekends, you can reduce your number of instances. you could use auto-scaling group to even put it into 0, minimum and desired 0, and have no instance running over the weekend, for example, and then put it back on Monday when people start working. That's another use case as well. One thing that it's a common term in the area is ASG 111. That's pretty much one minimum, one maximum, one desired. It's essentially to run one instance, but behind an auto-scaling group, not just the instance itself. That will be just because the auto-scaling group will, if you lose that instance, it will just create for you and will reconfigure as it was before. If you have a 111 instance on your auto-scaling group and you decide, oh, no, I don't want that instance anymore, and you delete the instance, what's going to happen is that the auto-scaling group will put another instance back. So you can't actually just delete the instance. You need to go and delete the auto-scaling group itself. You can, for example, if you have one instance on your auto-scaling group, one thing that you can do is actually transform that cattle instance into a pet. So there is an option that you can go and deregister from the auto-scaling group, and then you start managing that instance itself. The auto-scaling group will release the operations on that instance and will create another one to replace on the group itself. When automating the creation of EC2 instance, we need to be aware of two things. For example, if I need, when I create my instance, I need to, for example, install all my dependencies for my application, let's say NPM or Python or something like that. But I also need to install maybe some agents on my instance, for example, antivirus agents, or my company has this assets agent that I need to install, or it's for compliance things, any software that I need to install on the instance itself. Then you have two options of doing that. You can have a custom EMI, a custom image, where you have all your software installed on it already. The downside of that is that the softwares, once they get new release, you will have to keep updating the EMI. So for example, you're using Python 2, and then they release Python 3, you have to go there and generate a new custom EMI with the new version of Python installed on it. And you can use something called user data, which is a script that runs once your instance boots. So you create an EC2 instance, and you are able to pass a script. It can be a bash script, or I think it's a few languages that are acceptable. You can pass a script and it will run after the first boot just for one time. I think also there is an option that you can mark to run every time that it boots. A downside for this one is that if the user data fails, the instance will fail, won't boot. So that's an important thing. And we need to always plan to use as much as custom EMI as possible, because if you, for example, add a script to your user data to go and download Python from the internet, you make sure that every time that you create your instance, you want to go and download whatever latest version of Python is available and install on your image. So you do it with user data. But one day your instance are going to boot and the Python is not available. The website is down. You won't download the file, and the image and the instance won't start. So it's better to have that on your image as well. There's a few things that we can't do on the image itself. For example, adding an image to the Active Directory. You can't have that embedded on your image. It needs to be a command that you run once your image is running. A few agents sometimes is like that as well. Antivirus agents in enterprise, it's something that you need to register image instance per instance. So it's not something that you can have pre-installed. It's case in case. You have to make a balance and see what works best. But essentially, you can have packages pre-installed on your custom EMI, or you can use user data to run scripts. There is other options, not saying that it's the only those are the main ones. AWS has another service called SSM documents that you can, it's essentially a configuration management thing that you can send scripts to your instance. But for now, those two are good enough. Then you guys could probably be asking yourselves, how are you gonna, if you have 3 instances with a website running on it, how are you gonna access them? Like they have 3 different IPs. You guys have done exercise that you need to connect to the public instance and then jump to the private instance, and you use IPs for that to connect to one instance to another. If you have a website running, you have your one IP matching to that website, to that instance. And then if you have 3 instances, how come someone will come and reach one of those? You have to give your customers 3 IPs, like you decide which one you want to use. So it's not like that. That's where the load balancers coming into the play. Essentially, a load balancer service will receive will be like the front page for your users. That's the IP address or the DNS name that you will share with your customers. They will reach the load balancer, and the load balancer will have all the instances that are available at the moment, and the most common algorithm used is called round robin. Will send a request to the instance that are available behind your load balancer. So the customers come, on this example here, the public user comes, reaches the load balancer, and then the load balancer will send one request to each one of the instances available on your infrastructure. Ideally, you will configure your auto-scaling group to be available on different availability zones. So your ASG will create one instance on AZA and another one on AZB. You don't need, this is all done automatically. You just make available the AZs, the subnets, to the auto-scaling group, and that's the job of the ASG too. If it loses an instance from AZB, to create another instance on AZB, or if the AZB is off, to create on AZC, for example, and not having all 3 instances in one availability zone. AWS have 3 different types of load balancers: application, network, and classic load balancers. For this course, we will be touching just into the application load balancer. That's the most common one used these days for, I would say, more than 80% of the case. And that's pretty much what we'll be looking. It's mainly for HTTP and HTTPS connections. So application load balancer, or ALB. All those services, auto-scaling group, cloud configurations, ALB, they are all still under the EC2 service. So to find on the AWS console, you guys go to EC2, and on your left, you see all those other services available. Essentially, the load balancer is composed to 2 things: listeners and target groups. So listeners is the endpoints that are public available for the customers to come and access your load balancer. So for example, port 80 or port 80 for a HTTP connection, not encrypted, or port 443 to HTTPS encrypted connection. ALB can also have listeners based on paths, not just on ports, not just on 80 or 443, but also on paths. For example, your load balancer URL /home or /log or /profile or /store will send, and then once it reaches one of those rules on the listeners, it will send your connection to a target group, and this target group could be, for example, an ASG. So let's say if it reaches the load balancer on /home, it sends to the ASG that is responsible to handle the traffic for your home part of your website. It could be an SG, but it could be containers as well, which we'll be covering the next class, how to handle load balancers and containers and the ECS service. that's essentially it, theory about those things. We'll do a quick run, a quick demo on setting up an auto-scaling group and a load balancer. We'll see how it goes. I'll just cover these last two things here, quick one. So certificate manager. Well, when you have a service running on port 443 and you want to have the HTTPS, which is the encryption in transit, it's called. So your communication with the web server, it's encrypted. You need to have a valid certificate if your service is public, available on the internet. So, and then you need a certificate. I'm not gonna go through how certificates work because I don't even know really well by myself. But essentially, what you guys need to know at this stage is if your service is available on a port 443, if you want to use HTTPS connection, you will need a valid certificate. AWS have a feature called ACM, AWS Certificate Manager, where if you have a domain on your AWS account, you need to own a domain to be able to prove that you are the owner of that domain, and the services that are running under your domain are valid, and you own that. You can essentially create free certificates that AWS doesn't charge you for anything, but to be used with AWS services. You can't create a certificate, export that certificate, and use into a custom application or something like that. It needs to be used with AWS services, for example, a load balancer. So if you want to have your auto-scaling group with your application running and you want to expose as a HTTPS service, as a HTTPS to the internet, you can use the load balancer, and then you can install this free certificate on the load balancer to be available public. ACM can also do private certificates where you would have the option to export the certificates and use in a custom way, not on AWS service. It's a very expensive service, costs around 500 USD per month. And if you have around 1,000 certificates created, it can go like $5,000 per month, something like that. But essentially, certificates in general, public certificates are quite expensive service. And Route 53 is the DNS management feature on AWS. So everything related to DNS, Kiko mentioned a little bit about DNS on the network class. Essentially like a agenda on your phone. You don't know everyone that all the numbers of your friends and family. You probably will look into your phone, look for the name, and it will just call for you. The phone will know what number is linked to that name. So DNS works kind of the same way. Instead of knowing what IP address Google is running behind, you just type google.com on your browser. So all the services that you want to expose in a friendly way to the internet, you can use Route 53 to create names for it. And yeah, essentially, you can bring your own domain to AWS. You just need to point your DNS server where is your domain from to manage from AWS, or you can buy domains from AWS as well. I wouldn't recommend buying from AWS. It's a little bit more expensive than buying on, for example, GoDaddy or any other sellers around. So it's a little bit cheaper if you buy your domain outside and then just import to Route 53. To do some of the exercise, if you want to go through all the DNS exercise are optional. It's quite hard topic. It's not simple. It requires a little bit of knowledge around the certificates and how DNS works and how you get your domain managed by Route 53. So you don't require that to go through the exercise, but if you have the time, I think it's really worth to spend and trying to understand how this bit works as well.
And also, if you guys are not comfortable doing and need some help, feel free to reach us out because we're happy to help.
Yeah.
Just as Kyle mentioned, even being harder, don't be afraid of that. Just ask for help and we can help out.
There is a service called .tk. So it's the link, it's on the documentation. It's a free domain. You can get a free domain for that. Let me just jump into here because there is I don't know if they have fixed or not. So if you go to their website, and you look here, my super domain for, just to make sure that it's not being used for DevOps Academy. If you look for that and do check availability, everything that you try to get here won't work. You need to look for .tk. This bug has been around for more than a year, so it's most likely that it's still there. So on your search here, look for .tk, and then it will work the select here, and you'll be able to register for yourself. It's free. I wouldn't recommend putting your super project host in here. Take it with a pinch of salt on here. It's really good for testing, trying to understand how DNS works. Just it's not, if you're ever gonna run a business of something professional, buy yourself a domain. Don't just use the free ones. But it's quite nice to. So if you go through the process here, you will get all the instructions that you need to set up to move the management of your domain to Route 53. And then you should be able to see something like that. You should be able to see your domains and then create your records to expose your services. A quick note here, any zone that you create on Route 53 costs $1 per month. So there is a cost involved. I would say it's worth doing. It's $1 per month, but it's up to you guys. Again, all the exercise related to DNS, it's optional. You can still either using IP or the DNS that AWS provides to you, which is a long name, but still works. So every time, what I just mentioned, every time that you create a load balancer, AWS will provide you a CNAME, which is a record to be able to reach your load balancer. It will look something like that. It's normally a big string that works. It's public. People will be able to access. You could, if you are doing the DNS exercise, you can make this, instead of this big thing, my exercise.tk, something like that. Cool. That's what I had to cover with the theory part. And anyone has any question with that? I know it was quite rushed, but I want to, as you guys asked for more hands-on, I wanted to show on the console, at least show where the things are, to give you a heads up. Any questions? Cool. So AWS console, is it good if the size of the font, or it's too small, too big? It's good, cool.
It's all good. Oh, good.
So you guys have played a little bit with the instance here. As you can see, EC2 have a lot of other services going on here. So image EMIs, where you can see custom images, community images, as mentioned on the content. EBS, it's your like hard drives for your instance. A bit of network here, and then load balancing and auto-scaling. So I'm gonna go to auto-scaling groups. I'm gonna use a shortcut here, ideally, and what you guys will have to do with your exercise, and you will need to do through the CLI. So there's no shortcuts on the CLI. It's only the painful way. You will need first to create your launch configuration, or your, I think it's called, there is two these days. There's the launch configuration. This is another one. You need to create that first, which is where you're gonna tell what instance type, what EMI, subnet, VPC is, as mentioned, and then you will use the commands to create your auto-scaling group, passing as a parameter the ID of your launch configuration. Through the console, it's a little bit easier. You can straight go to create auto-scaling group, and then it suggests to you to go straight to the nice queue here. So this is everything that you guys will have to do through the console, through the CLI. I'll pick Amazon Linux 2. I'll leave it micro. I'll give it a name to it. No need roles, advanced details. I'm gonna use a quick user data here. What the user data is?
It's the script that's gonna run after the instance is launched.
Cool. I'm gonna paste a quick bash script here that is going to update the packets of my instance. We'll install HTTPD, which is just a web browser. We'll type these commands that I will get you guys to research about this later on. And we will start the web browser for me. It's a very simple script. I'm gonna mark the IP address type to assign a public IP address to all my instances. So every time that my auto-scaling group creates a new instance, I want to be public available. Remember from the exercise that it attached the IP. For that to work, I'll have my instance will need to run on the public subnet with the internet gateway attached to it as a route for it. My storage is fine. I don't need to change anything. For security group, I'll just pick, for this exercise here, I'm gonna use all traffic. I won't accept that as an answer for your exercise. Just for sake of working my demo. And then I'll start that. Choose my key pair to be able to access the instance if I need. Hopefully I won't need to access that. And then group name, I'll just give it a name again. That was the launch configuration. So I was only parameters for my instance itself, how the instance will look like. And now I'm configuring the auto-scale of the group itself. So on the group itself, I mainly need to tell what VPC it's going to run and what subnets it's available for the group to create new instance to. So on my account, I only have one VPC and 3 subnets. So I'm going to pick all 3. So that means that if I choose the setting on my group, the desired and the maximum to be at least 3, the auto-scaling group will create 1 instance in each AZ. What the size of my group? I'll leave it 1 for now. And that's pretty much it. If I am adding a load balancer to my group, I can click here and do an automatic configuration with the load balancer to the auto-scaling group. And then the health checks will be connected. So if the client's trying to reach if the load balancer can't reach the instance anymore from the auto-scaling group, it will send a request to the load balancer will send a request to the auto-scaling group to remove that instance from the group because it's not responsible. And then the auto-scaling group will create a new one and will register back to the load balancer. I'm not gonna do this right now. Scaling policies. I'm not going to create any scaling policies here. We won't have time to test that. But let's say if I wanted to create my auto-scaling group initially have 1, and let's say I want to increase. I want to have more instance if my application goes over some threshold. So my scaling policy will look something like that. Name, scale up, metric type. I will have some predefined in here. As I said, we could use custom ones. We'll get more into details when we cover CloudWatch into that, but I won't test, so I would just pick average CPU utilization, would say maybe 70%, and then how much time it needs to wait until it scales again. For example, wait at least 2 minutes before doing it again. So if I have this instance here, this scaling policy here, and here scale between 1 and 1. What happens if my auto-scaling group was running with 1 instance, then my application, my instance went over 70% of the CPU. Sorry, this I said that it was the cooling down, but it's not. This is how much time it needs to go over that 70% to trigger the scaling policy. Sorry about that. Okay, then the policy was triggered. I now have 2 instances running. And then, do I need anything to make it go back if I don't require that instance anymore for my traffic? So I essentially need to create another policy to scale down as well. And then you just need to keep adding more instance as you need. That's essentially it. So you will have scale up and scale down once it goes back.
Hey, Kyle, it says scale between 1 and 1.
1 and 1, yeah.
So it's gonna create the second one anyway, or not?
This is the minimum and the maximum. So this is at how many instances at least I need to always be running on my group, and this will be the maximum. So it can go from 1 to 5, for example, and then I will have my scale up based on the. So it changed my thing here because I went into the custom mode now, so it's not showing my.
That's fine. It's just if you have 1 and 1, you will never have 2 instances running at the same time, right?
Yes.
Okay. Yeah.
When you have minimum 1, maximum 1, your desire will be 1 as well, and then you won't scale. You can have the scale policies created, but they won't do anything.
Thank you.
You can have the policies. The policies will be triggered. You will see logs that the policies got triggered, but then it will just say, look, your minimum is already your maximum, so I won't do anything.
All right, thank you very much.
You can configure notifications. So every time that does scaling up and down, your instance goes off and start again. You can send a message to another AWS service called SNS, which can trigger emails, for example. And then tags and review and create. So I just create this one here. It says that my desire is 1, minimum is 1, and max is 5. How many instances are going to run right now without any issues happening?
1.
Just 1.
Yeah, just 1 because it's the desired one. It's showing 0 here because it's probably starting the instance. Yeah, as you guys can see, it's starting for me. I haven't gone through the EC2 launch UI to create a new instance. I just went to another service called auto-scaling group, and it's now creating the instance for me. If I go to my instance, I will have another one being created here. I'll just feel it's this one, initializing. I'll give it a name so we know which one is it. As it's a small instance, it will take a few seconds, maybe a minute to start. We'll give it some time. So what I'm gonna do next here is I'm gonna go to my auto-scaling group again, where it's showing now 1 instance. So I already have 1 instance registered, and the auto-scaling group can see that it is running. And I'm gonna go to actions, edit, and I'm gonna change the desired capacity to 2. What's gonna happen here?
I would say it's going to be another instance.
So essentially, it's going to create another one because it takes a few seconds until the auto-scaling group process the change on the group. So as soon as it realized that now the desired is 2 and I only have 1, I need to create another one. So you guys can see that it's creating another one. If I go back to that first one, that I give it the name, and I pick the public IP of that guy. If I go to my browser and try to access, that's what that script that I show you guys do. So it essentially expose the host name, the name of the machine, the instance, into a web browser. So this is an index page. It's just showing the name. I can see here the private IP, so 14246, and then we can match to see if it's the same. 14.246. So it's definitely that instance that is replying on that IP, and it's working. Cool.
And the two instances are going to be exactly the same. They are identical.
They are identical, but they have different names, right? That's what we expect. If I'm accessing the public IP of the first instance, let's call it first, and this one will be the second. What we expect when we go to this public IP, it's to now show this name, which is different from the other one, right? It takes a few seconds up to a minute to download the packets of the system, to install the server, and to start the web server.
So it's taking the same script that you gave for the initial. Is it that possible to have custom scripts for custom instances?
Yeah, that was a custom. So this was the script that I used. And I was using a service that just pretty much extracts the host name of the instance and exposes on a web browser. And I had different behavior from different machines. So this is the first one, 14.246, and that's the second one, 34.25. So it's definitely two different machines responding to this one.
But there is a single script for the entire launch configuration, right? So you can have two different scripts in the same launch configuration. You require a different launch configuration for that.
Okay, thank you. Yeah, that's what the question was, like, if you can have custom scripts for custom machines, like different scripts from one machine from one instance to another.
Yeah,
you need different launch configurations and different launch auto-scaling groups for that.
yeah. Your auto-scaling group will make sure that you have the amount of instance that you want, but they are going to look like exactly the same always.
Okay.
If you need different configuration between the instance, then you need that's your answer, that you need two auto-scaling groups. Now what we need is to have a load balancer or a single point of entry where our customers can go to that point of access, and or either go to instance one or either go to instance two. So that's when where we have the load balancers. So same EC2 on your left, just above auto-scaling, you will find load balancers. We're gonna create another one. As I said, 3 types of load balancer. We're gonna pick the application load balancer. We are gonna give it a name. Load balancers can be in 2 types, in internet facing or internal. The difference between those is if you choose internet facing, your load balancer will have a public IP attached to it, and it will be public available on the internet. Whereas if it's internal, it will run on a specific subnet that you choose, and it won't be accessible external from your VPC. It's useful as well when your application is only internal and you don't need to have that exposure to the internet. On our exercise, I'm pretty sure we will be touching just the internet facing one. As I said, listeners, here is how you configure what will be available on your load balancer, what the users will be able to reach. For this example, I will keep just a HTTP listener on port 80 or default. If I was to choose HTTPS on port 443, I will have to choose a certificate for it. And then I will need to have ACM working to be able to choose the certificate, which is not the case now. And then I need to choose what subnets my load balancer will be available. This is a tricky question here. If I only choose AZA, the load balancer will only be able to serve requests to instance running on that AZ. So they can't an endpoint of your load balancer running on AZA won't be able to send traffic to the other AZs. So if you want to have a high available environment, you need to have your load balancer as well enabled in at least 2 AZs. So I'll pick 3 here. It automatically chooses what subnet it's going to use for that one. And I need to choose a secured group for the load balancer as well. So I am going to make this faster. I'll just enable all traffic. And then I need to choose the targets. So my target will be called name. The type of it, it's instance. And will reach my instance on port 80 HTTP as well, which is where my instance were running that web server. So all defaults should work. And then AWS on the UI here, it gives me a list of all the EC2 instances that are available. I can pick any of those. I'm gonna choose the first and second. I will add to my group and I will create the load balancer. The load balancer takes a few minutes to be available. That's the DNS name that AWS provided to me. That should be public accessible soon. That's what I was saying before. This is enough to be able to do the exercise. If you guys want to create something more friendly and use Route 53, then it's up to you. This is the ACM UI. That's how it looks like. You have your certificates here. I have a few configured. I just want to mention two points here. So if you are creating a certificate to use with a load balancer, you need a regional certificate. So when you are on the AWS Certificate Manager, you need to choose the region to Sydney. If your load balancer is created in Sydney, then you will create your certificate here. But AWS also have this concept of global resource. For example, IAM, Route 53, it's a global, they are global resource, so they are not based on regions. But when they are global resource, they are, they run from US is one. So the first region here from the list, US is one. It's where all global resource run from. So if you are using a service, a CDN, a content delivery network that we mentioned on the first class on AWS is CloudFront. CloudFront is a global service and it runs from US is one. So if you need a certificate to expose your service to the CDN on a HTTPS port and have encrypted traffic, you need to create your certificate from US is one to be able to CloudFront be able to consume that certificate. That one should be up, hopefully. So I'm not using the IP from the instance anymore. I'm using the DNS, the CNAME DNS from my load balancer. And I got the 14246 here, what that means. So if I go back to my instance, first, is it first? Yeah, so 14246, 14246. So the first time that I got into my load balancer, it was redirect. So the listener was just the load balancer itself. There was no home or profile or any URL here. It was just the load balancer itself. And when I reached that listener, I can show you guys here as well. So those are my load balancer listeners tab. I have only one listener saying that when you reach to HTTP 80, no URL, just the load balancer itself, please follow this rule, which is forward to name. Name is the name of my target. Yep. and my target has two registered targets, which are the instance. So the load balancer will send one request to one of those instances available. So if I go back to that URL here, what I'm gonna do is I'm gonna hit refresh on my load balancer, and I can see now that the IP changed. So it means that my load balancer is doing round robin requests. So it sends one request to one instance and another request to another instance. If I keep refreshing here, we'll keep changing. It won't be always changing. Sometimes the load balancer can change twice my request to the same instance, but by default, AOB works in round robin. So we'll send one request per instance. And if I keep refresh, we'll just keep showing different instances because it's sending one request to each one. And that's it. You guys will have to do that using your favorite tool. Any questions?
By favorite tool, you mean CLI?
CLI.
It's gonna be much more complicated than a few clicks on the UI.
It took you like 15 minutes and you went through 300 screens. I can imagine the CLI.
Yeah. But it's going to be nice. It's going to be fun. It's going to be even harder when we get to Terraform doing load balancer and autoscaling group. It gets very complicated because it's a few resources that you need to create. They are all interconnected. You will see when you're doing the AWS CLI that you will have an option to link your autoscaling group with your load balancer. The way that I've done through this quick demo, I manually inserted my EC2 instance on the target. So remember, let me close one of those. So on the target group here, I manually added those targets. So if I lose one of those instances here, my load balancer won't have another one. There's nothing connecting the load balancer to the autoscaling group in a sense of, if my autoscaling group, do we still have time? No? How are we with time?
We have a few minutes if you want.
We can try to do a play here. So we'll go back to my autoscaling group. If you guys have any questions, please. Name, edit. I'm gonna change to 3 desired.
Mm-hmm.
So that's gonna create another instance, hopefully.
Mm-hmm.
Yep, getting a new instance here. I'll wait until it gets in service. But essentially what I want to show you is until it gets there. That's my load balancer name. It's not here, it's on the target group. Target group name. Target group is where you actually add your instance to. I have 2 targets. Let's see how this guy is going. So 3 instances in service on the autoscaling group, and on the target group, I only have 2. So my load balancer doesn't know that I'm getting more instance, and it should start now giving request to that new instance as well. So I haven't done the link between the autoscaling group and the load balancer. You guys will see when you're doing with the CLI that we'll have an option that you link both of them, and then every time that the autoscaling group register a new instance, it will send a message to the load balancer and say, look, I have a new instance here, you can start serving, it's available for use. And the same if the autoscaling group queues one of the instance, the load balancer will stop sending the request to that instance as well.
I thought it is default behavior. Okay.
It is when you create your autoscaling. When you're creating the autoscaling group, we will have an option to link to a load balancer, and then it will create the load balancer for you in that case. if you do that the way that I've done it, I created the auto-scaling group and I created the load balancer because I wanted to show you guys the difference of creating both resource. It's not linked.
Thanks.
I have a question. So, is the load balancer allowed to add rules such as if someone is accessing the website through, for example, Australia, go to this instance, and if he's accessing from US, go to the US instance, for example? Does the load balancer accept those sort of rules?
Load balancer, listeners, when you create a new listener here, the AOB is quite complex. You can have that they have something called advanced routing paths. I don't think it can be done geographical rules. I don't think that's an option, but you could have something maybe on your header on your request, and then you can have a path saying, for example, /US, sending to a target group to a specific target group. Whereas if you go to /AU, it sends to another target group that is maybe living in another VPC or another region, for example. That's something that you could do.
Okay,
Yeah,
nice.
I use Route 53. Route 53 is able to send traffic to different IP addresses or different load balancers based on the location that the request is coming from. So probably is the best approach to solve that.
Yeah, it's not the. I was trying to just keep on the load balancer itself. It's the load balancer wouldn't be the right tool for that problem. You can use Route 53 when you're creating your DNS records here. It has a few options of how you're gonna match the research that is behind that DNS. So it could be by weight or by if it's what is the all the names? It's 3 of them. It's geographic. It's based on the latents, based on the weights that you configure.
You also have round robin as well.
And round robin.
I can send one to
Yeah, routing policy.
Thank you.
So you have a few. One of them is geolocation, and then you just choose different values for your record. So we'll pretty much have 2 values here of load balancers. We are not going to cover that on the course. That's very advanced.
So I have one question.
It's good to know. Thank you.
I have one question. Once the auto scaling groups are created, can't we edit it?
Can be a what, sorry?
Can we go and edit the auto scaling group to say that configure the load balancer?
I'm not too sure if you can add the load balancer. I don't think so, but I could be wrong. I'm not sure. Because that is an option when you're creating the auto-scaling group, okay, to have that linked with the load balancer. Also, an interesting thing here on auto-scaling group and launch configuration. The launch configuration can't be changed. There is a new service called, what's called? So if you use launch configuration for the auto-scaling group, this one here can be edited. So this one here is the one that saves the size of the instance, what AMI, subnets, those kind of things. So this one can be changed. If you need to replace, you need to delete and create another one. And then you need to refresh your auto-scaling group, like create new instance. And this one here, it's a new feature, launch template. This one can be edited. You don't need to delete and create the resource itself. If no one has any questions, I'll pass to Kiko because he have a lot of content to go through as well. Well, you guys want to do a 5 minutes break before jumping to the next one? Or are you happy to continue?
Thumbs up, down.
3.
I'm happy to have a break.
About
Just
3
5
minutes.
minutes. That's fine.
5 minutes then.
Yeah.
3 plus tax.
Okay, 5 minutes. Just to stretch the legs.
Got a coffee.
I'm glad that the demo gods are in my favor today. Without any run through first, everything seemed to work.
Yeah, it was a good demo. A good class too.
Yeah, it was great. It was really great. Thank you. And I'm also impressed that your bookmarks bar is so empty. You don't have anything bookmarked on your Chrome, and it's like, what? How's that possible?
I remove it because it's the one that I use for the class.
Ah, okay, that's fair enough then.
I think that Daniel added you to another channel, but I think it's nice to mention as well. Daniel have been sharing his screens a few days during the week as well when he's doing his exercise. He's opening a Zoom channel and offering help.
Yeah, that's good. He reached out to me and he offered help. That's pretty nice of him. I end up doing so. My background was meant to be development, and I started doing. I don't know if you know or if probably know Rocket Seat. So they have the Go Stack Bootcamp, and that started with DevOps. So I was planning to do the bootcamp, and then that started with DevOps. So it's
So they created content for DevOps in the Rock Seat?
no, not yet. They do have content for that, like in the previous bonuses, but the new one, the new bootcamp, it's we just got on week 4, and but they haven't touched DevOps yet.
All right.
But I think he will when he talks about deployments. Week 3, he mentioned Docker. So we are using Docker to connect to the database. But it's also pretty full on. It's just like all I've been doing with my free time. It's either Rocket Seats or DevOps. It's all I have been doing.
Yeah, his course is pretty great.
I saw that
I took some. I followed some tutorials on React Native, and it was pretty good.
Yeah, I saw that you have him on LinkedIn, and I thought, oh, maybe he did a boot camp.
Yeah,
he's pretty good. He's pretty good. Like the boot camp is pretty full on. The application and how they build from scratch. It's good. I'm really enjoying. And
right.
I don't know if you guys missed this, but some cheese breads. Does anyone want some?
course, I want to.
We don't have we don't have anyone from Minas, do we? From Minas Gerais, no?
No, we do have
Daniel is from
Daniel.
Minas. Daniel is from Minas, isn't he?
Yeah, Daniel is.
Oh, okay, cool. You probably have a cheese bread than I do, but anyway.
Is it custom made? Homemade?
Yeah, homemade. My partner and I, we went to Brazil in January, February, and we bought like 6 bags of full of
Tapioca?
not tapioca, the amido. I don't know how you call that.
Ovilho.
Correct. Yeah. So we have plenty.
So it's a pattern now. We need to have a student that knows how to do cheese breads on each group.
Yeah, it was Denise on the previous one.
Oh, really?
Yeah.
Yeah, it's pretty good. It's like I was so addicted in Brazil, and yeah.
I'll buy here on Costco. It's pretty good from Costco.
I don't have the membership, and Costco is a bit far from my place. But we found that cheese bread on Woolies, they do sell like a package. It's good. It's good.
Should we start back, guys?
Yeah.
Cool. Let me share my screen here.
Yep.
Hopefully you guys can see it.
It's fine for me.
Yep, awesome. So yeah, this class is about containers, and container is very common in our daily jobs. We use that a lot for testing, for even production. So it's one of the key pieces of a DevOps toolset, I would say. And containers, I mean, it's basically a unit of software that pretty much packages everything that an application needs in terms of application, not in terms of operating system, but just in terms of applications, and just create a package of that, right? So as you can see in this diagram here, a container is pretty much a layered system. So it's a bunch of layers on top of each other that pretty much brings all the requirements of the application, right? So if you have, for example, a library that your application need, some package patches, a service that is required for the application to run, the application binaries, then the application config. Each of these layers is a file system inside the Docker, not in Docker, but in a container. So it just layer up. So imagine as a cake, you have all those layers of cake, and in a container is pretty much the same, right? It's just a bunch of layers on top of each other. Dennis, I think Guilherme dropped it. If you can just bring him back.
Yes, thank you.
Thanks, man. And why we use containers, right? I mean, we used to use a lot of virtual machines back in the past, and I normally say that the container is like an evolution or a new way of delivering things, because we used to have physical machines, then we have virtual machines to make better use of hardware, and now we have containers, which makes better use of both hardware and the operating system, right? As you guys can see in here, normally in a virtual machine environment, you have the hardware itself, the infrastructure itself. So 16 CPUs, 128 gigs of memory, disk, and you have the machine that needs to be split between multiple virtual machines to make better use of that hardware, right? So you used to have a hypervisor, and that could be VMware, Citrix, then Microsoft also had Hyper-V. So you have any kind of hypervisor, which is a thin layer of an operating system here that talks with the hardware directly. and then you have all your VMs on top of that hypervisor, right? So you'd have one Windows 2018, another Windows, I don't know, 2008. So you'd have multiple operating systems, and in some cases, the same operating system. So you could have multiple Windows 2016 machines running on top of this hypervisor that would probably maybe provide the same service. So you could have multiple servers providing the same application here, right? So what happens with VMs is that all this space here, this piece of this diagram is being repeated all along those, as well as the application, right? But this normally consumes for a Windows something around 16, 20 gigs. For a Linux, maybe 4 gigs, 3 gigs. So it's a lot of disk when you talk about thousands of virtual machines, right? And one of the difference between a virtual machine and the container is that the infrastructure is the same. So you'd still have here the same hardware that you'd have, but on top of here, you normally have an operating system, and that could be either Linux or Windows. And what the container does is instead of having a hypervisor, you have, for example, Docker here, which is one of the containers providers that we have, one of the containers software providers. And what happens is that the container would use the same operating system here. So if you have multiple applications, or even if it's the same application, the containers will be sharing the host operating system, right? So instead of duplicating the operating system, you save a lot of resource and being disk, and also being in terms of CPU and memory consumption, because the operating system itself is not being duplicated, right? So the only piece that it will be duplicated between the containers would be the application itself, and you can also run multiple applications making use of the same operating system. So the basics here are in terms of the containers will be the same. So you can have, for example, Windows containers and Linux containers running on a single operating system. You need a dedicated Windows operating system to run Windows containers, and a dedicated Linux operating systems to run Linux containers, but you still save a lot of time in terms of time to boot the container, and especially in terms of resources, CPU, memory, and disk. They are very similar in some ways in terms of resource segmentation. So what is running on this virtual machine in a virtual machine environment cannot be accessed by the virtual machine on the side. And in terms of containers, it's pretty much the same. What this App7, for example, has access in terms of the application layer, the application 6 will not have any access. So they do not interfere between each other. They do not share the resources in terms of being able to use the same resources at the same time. They use the same operating system, but Docker makes sure that everything is segregated between all those containers, as well as the hypervisor does the same for the virtual machine case. Some of the key benefits of containers is because of you abstract the operating system layer, they are normally really, really small. And I can show some of the image that I have here. And those are not the best use case, to be honest, but we have one Docker image with 165 megs, 31 megs, 414, 73, 64. So you can't have a virtual machine of this size, right? Normally virtual machines are on the gigs, so maybe 5, 10, 20, or something like that. And the containers will be in the orders of megabytes. So normally, especially for Linux, you're gonna have containers ranging around 50 and 200 megs, maybe a little bit more depending on what you have. For Windows, is normally a little bit more, but it doesn't compare with virtual machine size, right? So that makes one of the key things of containers, that it's easy to move things around. So you can pretty much create a container on your local, and to upload something with that size is much easier, right? So it's easy to move things around. Another great benefit of a container is container where you send the image. For example, you have your image in your local and you send your image to run in the cloud. The behavior will be the same because everything is packed in that container. So you have similar results running everything that you can develop really fast, because you can test things as you develop on your local without requiring resource being provisioned or waiting for someone to create a virtual machine so you can deploy your code. So you just run everything local, and because you're using containers, when you move into a QA or production environment, the behavior will be the same because everything is containerized, right? So that's the three biggest benefits of containers, I would say. And make sure you learn this, because for sure, if you land in a DevOps role, you're probably going to be using containers in some ways. I've been talking a little bit of containers, and I mentioned Docker, but Docker is not container. Docker is just the most common container options that we have in the market. So it's really deeply used when you have containers being mentioned, but it's not the only one, right? We'll cover here Docker because it's the most common, but make sure that if you're interested, there's a list here that have a few other flavors of containers solutions. Okay. Docker is composed mostly by three components, which is the Docker client, the Docker daemon, and a registry. And they interact between each other all the time, right? So the Docker client is pretty much where you have the CLI. So here I have, for example, Docker version, and we'll show the CLI version, the client component of the Docker. But I also have the Docker engine here, which is the Docker daemon, right? So normally when you install Docker on following the instructions from Docker, you're gonna have those three components in your local, but I could configure my Docker client to communicate with a Docker daemon running somewhere else, right? And the Docker client is pretty much just this Docker CLI here, Docker, which will pretty much do all the commands and interact with the Docker daemon directly, right? So every command that I run here, for example, Docker image ls, it's the client communicating with the Docker daemon to provide that answer. Docker ps, same thing. So everything that I run is using the Docker client and communicating with Docker daemon, which manages the running of containers and all the components that we have in containers, like images and the containers itself, right? So the Docker daemon is pretty much a REST API service that has a service running on behind and receives all those commands from a Docker client and executes and return back. And the main things that you have on the Docker daemon is the image management, which as I show here in this command, Docker image ls, which just shows the image that this Docker daemon knows, and also the containers that are running or have run on that Docker daemon, right? So every container that you run will require a Docker daemon to run that container properly. And you have here all the ports and all the communications that happens between. These you guys probably won't be using on your local. It's just important when you're interacting between a Docker client in one workstation and the Docker daemon running somewhere else. Then you might need to open firewall port and things like that. But normally, if you run everything local, you should be fine in that area of ports. And the last component is the Docker registry, which pretty much is responsible by storing Docker images, right? So you can have a Docker image that runs Apache, you can have a Docker image that runs Nginx or MySQL or I don't know, you can think, and you probably have a Docker image for that. But the interaction between the Docker daemon is that if you ask through the Docker client to run a Docker image that it doesn't have on the image that he knows, Docker daemon will just reach for a registry, which is normally Docker Hub as a standard one for Docker, and we'll download that image from Docker Hub, and you'll bring that image to that local where Docker daemon resides, and we'll be able to run that Docker container using that image, right? Any questions up to this point, guys?
Good.
Oh, good, cool. On the Docker client side, there are a few main commands that you use. You have multiple commands here, so you can use -- help, and we'll provide all the commands that you can have here. But I'll just cover a few of them, and you guys can dig later if you want. But the main one is Docker run, which is used to run a Docker image. And when you run a Docker image, the image is immutable, so that image will never change. What Docker does is gets that image and runs a container from that image. So that container is separated from the image itself. So it's an instantiation of that image. And from that point, that image remains as it is, and everything that happens in that containers just belongs to that containers. Anything that you create or install or change or run, it won't affect the image that you have, right? So the image remains there as it is. But the Docker run will just get an image and execute one container based from that image. The Docker build, which is the command that you use to create a new image, and we're gonna go through some hands-on here to create a new image using this Docker build command. You use a Dockerfile, and I'll show you what a Dockerfile looks like in a few minutes. But it just creates an image and saves that image on your Docker daemon, basically. Docker exec is if you have an image, a container running, you can execute commands on that container. So if you have a container running and you want to list all the files that you have there, you can just Docker exec into that container with an ls command, and we will execute that command and throw the result into your standard in, right? So standard out, sorry. So it's just for execute commands in a running container, this Docker exec. Docker image is to interact with the image that the Docker daemon knows. So you can remove image, you can pull image. So again, and that's something friendly from Docker, similar to AWS CLI, but if you just Docker image dash help, you'll show all the commands that you can have. So history, import, inspect, loads, prone, pull. So every command that is related to image itself. Docker PS, for anyone that is familiar with the PS command in Linux, or I think Mac OS as well, is the same purpose, is just show what is running in your Docker in your Docker daemon. So here I don't have any containers running, so it just returns an empty list of containers running. But if you have multiple containers running, you'll provide all the informations around those containers. If you want to interact with a specific action about a container, like removing containers and things like that, Docker container and the action. And for Docker image, as the basic things, the most common commands. But as I showed through the command line, there's a lot more. Any questions on this? So you won't be able to run or create anything.
Yeah,
but
sorry, you can.
If you use if you use WSL, you can, but in a pure Windows, you can't, right?
On WSL2, it's easy to do that. And like, I gave up my Linux like 1 month ago after that.
So yeah, but it's what people say. Right? Yeah, WSL.
Two,
Yeah,
yeah, so the
it's
two.
a Linux. Okay, it's fine. It's a Linux. WSL is a Linux, so you can. But if you say running a command prompt or a PowerShell, can you run a Linux container? No, you can't. So
No,
if
you can,
WSL,
you just select the context now. Now you can select the context if you are running the Windows or on the Linux.
yeah, because we use WSL, right?
No, I'm gonna send you a screenshot. Yes, you
Okay,
can.
cool. I didn't know. I normally use just Linux containers, and I use Linux and macOS. So I
That's interesting because for the containers, you need you using the operating system, the underlying operating system, right?
Yeah.
So that's interesting.
That is possible because Windows is running or have a Linux running that will make use of all those library, all those kernels.
Yeah.
That's because the Docker for Windows, it's installing the minimum kernel, the minimum software necessary to run the Linux containers. But if you don't have the WSL installed, you will have issues running Linux.
It
It
got
could be simple ones, but it will have issues.
got much better with WSL2, but when you install Docker for Windows, you get to choose if you want like Linux or Windows containers. So the way it runs in the background, like the engine. So
the Docker for Windows installs it, the Linux context.
Kiko, the usual commands. Can we add Docker logs as well? I found it very useful.
Yeah, you're right. Docker logs is used mostly for get logs from a container that's running. Yeah, it's something useful. I can add here for future registries where we have the image stored, and it can be a public or private registry. For public, normally we talk about Docker Hub, and for private, normally you can use AWS ESR or same services from Google. Artifactories are very common to use it in most companies, and Docker Hub is pretty much it. You can find pretty much any image here with anything that you want. So Apache, Maven, Solr. If I want MySQL, MariaDB, MassSQL. We're gonna have some tools here about MySQL. So pretty much any tool that you can imagine or any service that you can imagine, you're gonna have an image here on Docker Hub, either from the vendor itself or created by contributors, right? But yeah, just if you don't think that, if you don't find an image, you can create your own and just push here and make it public so people can make use of that as well. And basically what you have is, in all those images is exactly what I showed before. Is just the package that an application requires to run that specific code, right? Something that I forgot to mention, and I think that is important in terms of a container, and sorry for missing that. A containers, and this is a big difference from VM. A container is normally running a single process or a single main process, and the container lives while that process lives, right? So normally you won't have, for example, in the same container, a web server running and the database running. You could do that, but it's not ideal because you should only have one main service, and if that service terminates, the container should terminate. And if you have multiple services, you might drop your database because your web servers dies, or you might drop your web servers because your database dies, basically, whichever is the main process running that container, right? So the container should have just one process running and should be responsible only for that process, and that's it. In terms of Docker image and how we create Docker images, as I mentioned, it's through the Dockerfile. And let me just jump in here into the class tree. Probably gonna be easier to show things. I have here already. Yeah. So a Dockerfile is just, as I mentioned, is just where you create the image, and it's just based from a bunch of instructions, and you can have multiple instructions here. You normally have a few instructions, and the main one will be that from. Then you have run. Sorry, the from is, every image is based on another one. So in this case, I'm going to create a new image from this Docker file that will be based from this image here, which is HTTPD, which is Apache and a specific version. And in my new image, for example, in this case, I'll run just one command that will be just generating some code into the index HTML of that Apache web server, right? But you have many more commands. Again, the list goes on, and I have just a few of the main ones here. As I mentioned, from is just to inform which image your image will be based from. Copy, to copy commands from your local to the container image itself. Add has a similar to copy, but it can add files from external, like HTTPS. Run is to execute a command during the build of the image. So if you need to, for example, install a patch or install an application, you just run this run instruction to run that. Env is just to create environment variables inside the container. Expose is it's just to expose a TCP or UDP port from the container. It's just for documentation's purpose. It's not required to have an expose to have that port listening from the container, but it's normally a best practice to have the expose to make things more clear in the Docker file. User is just to specify which user account will be used to run the container once it runs. And CMD and endpoint, they normally interact between each other. The CMD is just to set the default command and the parameters that will be executed when the Docker is run. So if you just run Docker run and specify an image, you use the CMD that is defined as the default command to be executed. So that will be the process that once it dies, the container will die. And the entry point is when the container needs to be run as an executable, you input the command inside the entry point, right? So the entry point, normally it can be overridden, and the CMD, they can be overridden during the container execution. And the work dir, if you're executing commands during the Docker build, you set the work dir to inform which directory your commands will be executed. So the run, the CMD, everything will be executed from that working directory. Cool. So if you use that that image as an example, and we try to run some Docker commands here, let me jump into that folder. So there are 3 Docker artifacts. So the Docker file is that same one. So from HTTPD and running the echo to input some data into the index.html. So if you want to create that image, you just run Docker build. You inform a name for that. So let's say da-laser301, and you have the name. And normally the Docker image name has a name and a tag, and this tag is really important, specifically when you have versions and specific information that you need to provide, either from what container image this image is being based from, or if it's an application versioning. So it's nice to have something that is meaningful here. In our case, we don't need that, so I'll just use v1 here, and you have this space and dot, which is from where this Docker build will run. So because we are in this folder and the Docker files is here, you just use this folder as, let's say, from where this Docker build will be built from. So this will just Normally, you just download the Docker image that we are basing for. I already have this image here on my local just to avoid spending time downloading that. But as you can see, you have two steps here, right? The first step is the from, which is the first command of the Dockerfile. And the second step is the execution of the run instruction, right? So it just executed everything and created the image. So if you just run docker image ls, we have this new Docker image created like 27 seconds ago with 165 megs because it was based from this HTTP, which has 165 megs. So that's pretty much how you create an image. It's pretty simple, pretty easy. The main components that it's important is on the Dockerfile itself. So depending on what you need to do, what you need to install, what you need to configure, that's where your Docker image logic will be pretty much. So this is a Docker image with an HTTP Apache service running. So this is the purpose of that. So what we can do here is just run this Docker image. So we can Docker run the name of the image and v1. So what we need to do here, we could pass a lot of parameters here, like if I want to mount something that is my local into that image. If I need to pass any environment variables, I'll do through that command as well. But here I don't need to do that. The only thing that I need to do is to connect my local, so this machine that I have, with the Docker itself by doing port mapping, right? So the Apache normally runs on port 80, and that would depend on what kind of Docker image that you're using. But in that case, it's a web server, runs on port 80. And I need to make sure that when I run that container, I just map that port 80 to a port on my local. So at this stage, for example, if I just run netstat that in, which will just show all the ports that my computer here is listening, and this is the port. So there's nothing running on port 80 or any other port besides those things. So I can safely run a command like docker run here again with -p, which is the command to expose a port on my local and forward that to the container port 80. So for example, 8080 to port 80. And again, the name of the, so this will be running this container, the class p1, exposing the port 8080 on my local and sending all this traffic to port 80 on the container itself. If I just run here, so this is the logs that Jay mentioned. So I'm not running a detach mode, which would be just run and forget. I'm running with the logs running here. And if I just open a different terminal here and just run the same netstat command.
This is what the expose command will also do, the -p that you did.
Yeah, so let me just show here. So listen. So now my computer is listening on port 8080, right? So I have an open port on my computer. And if I just run docker ps here, it will show that I'm running this container, and all traffic that reaches my computer on port 8080 is sent to the port 80 TCP of the container, right? So if you go into the browser here and just say localhost port 8080, I have my container running and the response from that. And that's where we say that that's very beneficial for development purpose, because you can create your application, your web services, and run the Docker and see if that's working properly, right? You could have multiple Docker images running, you could have a connection with database and so on and so forth, and everything will be properly working fine. Any questions on that process of creating an image and running an image, guys?
How do you solve the problem if, for instance, if I will create a Hadoop service and a Spark service that depends one to another?
Yep.
I need to create two images.
We'll jump into that. I'll hold your question. We're gonna have something else here, which is Docker Compose in a few minutes, and I'll answer your questions there.
Okay.
Cool. Sorry, man, but yeah, it'll make much clearer there.
Oh, that's fine. Just thinking about
Yep. Cool. Any other questions? There are some best practices here around creating an image. Always use the tag in the from instruction. That's because if someone changes the tag and if you're not tagging, it will normally default to the latest tag, and the latest tag might install a different version of a base image that you need. So you're running on Apache or in Python 2, and now the latest is pointing to Python 3, and your application might break on that. So it's important to use a tag. Another good thing to do is, as I mentioned, because all the layers are tied together, and as you can see in this example here, so every instructions that you have in the Dockerfile will add a new layer to a Docker image, right? So you can see that everything will stack together. So try to make sure that in your Dockerfile, the instructions that change less, for example, if you're not changing your application, so binaries that you install or that are not is not changing very often, are instructions on top of the image, because you can make use of the caching of image. So because every layer is tied to an image, but it's also known for Docker daemon as a separate layer. So if you have another image that can make use of this same layer here, instead of building that image, that layer again, Docker will just grab that layer that already exists and bundle into your image. So it saves some time if you have multiple Docker builds running, because you're changing your code, your application, and you can save some time, and that's probably a better approach if you can. I won't go into much detail here. You guys can read and go through that later. It's something nice to read and know, but I won't have a lot of time to cover that today. So, but yeah, everything that you change in a previous layer will affect the future layers, basically. So try to make sure that you have the last changing instructions on top of your Dockerfile as a best practice. Cool. For Docker, that's it. I won't cover ECS or ECR in this class because we are covering that on next class. Any other questions before I jump into Docker Compose, guys, from Docker?
Hey, Kiko, I do have one. With that Docker image that you are running currently, can you interact with that? Like, I mean, by interacting with the server running?
Yep.
Or do you have to run detached mode and
so because it's running, I can execute Docker exec command. So if I just Docker exec, oh, sorry, I need to use here the Docker image name. And if you don't specify a name, Docker will create some funny names. It has two lists of names and just will make use of those lists to create the name of the container here. So what I can do is Docker exec, and I can just in an interactive mode, which is the -at, and just execute bash, which is the a shell terminal, right? And now I'm on that image pretty much. So if I want, for example, to change the index, for example, here, right? If I want to echo new HTML file into that index, oops, sorry, that index file, I just interact with that, and if I go back here and just reload, it just changes what is running, right? So you can get into the Docker image that is run, sorry, Docker container that is running, and make all kinds of changes that you want here if you want.
That's pretty cool. Thank you.
No worries. You can also run without here. So without the interactive mode, you can exec, for example, ls la bash dash, sorry, and it's just listing what is in that file system in the root folder. So you can run pretty much anything you want against that container.
Thank you.
Any other questions, guys? And for Docker is not simple. I mean, it's simple in some ways, but it's really complex if you start to dig deep into that. We are just trying to cover the surface here, and during the exercise, you guys gonna have a lot more deep into that. Cool. If no other question, I'll just jump into the Docker Compose. And Docker Compose is a component of Docker. It's normally not installed with the Docker installation that you guys did. I might be wrong, but I don't think they changed that. So you're probably gonna need to install this this tool. What Docker Compose does is pretty much if you need to run multiple containers that interact between each other on your local, then you start using Docker Compose to facilitate that. You can use Docker and run everything manually, it's fine, but it becomes really painful if you have more than 2 or 3 containers that needs to interact between them. And Docker Compose just comes to help on that matter, right? I'll just jump into this Docker Compose file here to explain a few things, which is probably easier to show. So we have this class Docker Compose YAML. This is a very simple Docker Compose. It just have 2 services. Basically, your Docker Compose normally starts with a version that should be used by Docker Compose to interpret this file. And this file is pretty much what the Docker Compose CLI will use to run all your containers that you want, right? And each container that you need to run is defined as a service in the Docker Compose file. So here I have 2 services running that should be run when I start this Docker Compose. The first one is called web. This web is being built from the dot. So I also have a Dockerfile, and you can have these in the Docker Compose. Oh, sorry, I just lost here. In the Docker Compose, you can build an image during the Docker Compose execution, or you can just specify an image as I'm using here for this Redis Alpine image. But here I'm just saying when you execute this Docker Compose, just build the image that resides on this doc, which is the Dockerfile here. Again, this is from the image that I'm using. I'm defining the work dir. I'm setting some environment variables here, running some commands, copying the requirements from my local to the requirements to this work dirs folder. Just running pip install, which is a tool to install Python libraries, and copying the app.py and running Flask, which is our web server to run Python code, right? So this is what will happen in this build process here. And I'm saying that I want to expose the port 5000 of the container into the 5000 of my host, right? Similar to the Docker run -p. And this port is defined here. So
may I ask a question?
You just did it for Flask, sorry. So, yep. What's the
on your Docker file on the CMD? I know in this part sometimes you can use CMD or entry point. What's the difference?
The basic difference is that CMD can be replaced. So you can, for example, instead of when you run Docker run, you can specify the CMD as a different command, and will not run the CMD. The entry point will always be executed no matter what you try to specify.
Kiko, just a small correction there. There's a way of overwriting the entry point.
Yeah, you can dash entry point, right?
Yeah, dash entry point. But understand that you'd like to use entry points for fixed commands and the CMD for arguments, usually.
Yeah, the CMD in this example here, if I want, for example, I'm running the DA class, right? It will run the CMD if I'm not specifying anything here. So if I specify bash, it will not run you'll not run the Apache service, right? So I probably won't be able to execute and to get into here now anymore because the Apache is not running. So when I said that I can replace, is that I can replace through this command here. CMD is what is being executed here. And if I don't have anything, it will just execute what is in the CMD. But as Dennis mentioned, and you're right, Dennis, the entry point can be replaced by the dash entry point if you specify.
The main difference is that what Dennis said, the CMD, you can pass arguments, whereas the entry point, it's a command itself.
So if you have more than one CMDs there, and if you pass in just one argument, which one would it pick? Like which CMD that it would override?
I would say the last one because it's the last layer in
I
the
haven't tried this. Yeah.
Yeah, I never tried, but I would say it's the last one because of the layer model of containers.
I think it will run all of them.
Yeah, I think too. It will just concatenate and run entry points plus commands. So it needs to, both the entry points and CMD need to make sense. And if you have a bunch of commands like a script you want to run, probably you'd like to create a file.sh, for example, and just call this file, this script to be executed.
Okay. Instead of having a bunch of command there.
Yeah.
Okay.
Yeah, usually we don't do this. You create a separate script.
Before. Yeah.
I'll try that later, but I'm not sure.
I was just curious because I never tried it.
Yes. Thanks for the explanation.
So yeah, here we are just specifying the port that we forward, and here is just the an Alpine Redis Alpine running, which is we run just a Redis container here.
Just one query. The
Yep.
image that is, in this particular YAML file, the image, and in the Docker file, there is a base image. So, I mean,
yeah, because the Docker file here, will be used by this service here, the web, which I'm building this Docker file on the runtime. So this service here, which will be one container running from the two containers, we will use the Docker file. This one we use that image.
So this is another container. This would be launching.
Yeah, this one is one container, and this one is another container. So we'll be running two containers here.
Thank you.
No worries. Cool. So if I just jump into that folder. So same folder. So I can run Docker compose up and see it's building the web container because I'm saying that I need that to be built during runtime. Because it has all those installations, all those yum install and pip here, it's just running this GCC must, so it's running this command now, installing all those prerequisites, and it will just be executed after the build process.
Kiko, one more question. If we have more than one Docker files over there, what will happen?
By default, we use the Docker file itself. If you need to specify a different Docker file, you need to, for a Docker build command, you specify -f, which specifies which Docker file you're using. But by default, you use Docker file.
Thanks.
So yeah, both containers are now running. So you can have here, you can see Redis 1 and Web 1. And if I just move to the other one, if I run Docker PS, now we have those two containers running one forwarding 5,000 to 5,000, and the other just exposing TCP. And Gustavo, when you asked how I would do it, if you see the Docker file here, sorry, the API, I'm using here the host of Redis, right? So this could be sent through environment variables. In this case, I'm not using, but this name reflects the exact name of this service here, right? So if I change this to Redis 2, oops, sorry, to Redis 2, that will break this because you need to, you try to find the Redis inside our, my Docker Compose execution, right? So all containers inside this Docker Compose can communicate between them using those names of the services. So if I connect to Redis and try to ping web, we will find the web server here. If we just run local 5,000 here, so that's my web application, the Python running, connecting to my Redis server and say that I have one visit here. If I reload 2 times, 3 times, so now it's pretty much a database being queried, get information and providing to the container. So the 2 containers are communicating between each other now. And that's simple. I mean, you could have a MySQL and a PHP application running here and everything communicating and running any kind of web application pretty easily on your local with that. Any questions in regards to this Docker file, sorry, Docker Compose file and how it works?
For now, that's fine.
If I just Control-C here, I'm just stopping both of my containers now, and you're gonna see that Docker PS already stopped at 1, and now as non-run. If I run a Docker PS-A, it will show all the containers despite they are running or not. The PS just shows the Docker containers that are running at this stage. Docker PS-A will show both running and previous containers that are already terminated. As you can see here, the status of them and the name of each container that was running with the image that was used, the command, and yep. So that's very useful to troubleshoot and understand why is my container is not running. So the status here will show something that might be useful. And then you can also run the Docker logs. I don't think I can run Docker logs for a container that already stopped it. Let me just check Docker logs. Oh, yeah, you can. So I can just grab all the logs and see what happened in that container. Cool. Any other questions before I jump out of the Docker Compose? There's not much of the Docker Compose. It's pretty simple. You can run on as well on -d, which you would just a detach mode, and in order to stop, you can run Docker Compose down, which will put all services down, and all the commands. That's probably important. All the commands that you execute on Docker Compose, you use the current directory. So if I just move out of here, so and try to run the same Docker Compose up, I won't have anything. So it's probably running. I have no idea why it's downloading anything, but it's probably just running from the folder. But normally we use just the Docker Compose file. It's probably just some random thing. I have no idea what's that running.
Running the render for the Git class.
Oh, okay. Yeah, so that should, yeah, I don't have any Docker Compose. So that's what I was expecting here. So yeah, normally you need to run the Docker Compose from the place that the Docker Compose YAML file is located to make sure you running the right Docker Compose. Cool. I'll jump into make. We have 15 more minutes. It's probably going to be pretty tight to run through make, but I'll try to see if I can run everything. Otherwise, we might need some 5 to 10, maybe 15 minutes extra from you guys for today. But yeah, let's see how it goes. Makefile is make itself is another tool that we use a lot, especially if you run multiple things a lot of time and you need a process to I won't say consolidate, but run, let's say, receipts that will run multiple commands in sequence, something similar to a bash script or PowerShell script. But make has some benefits that over those tools, I would say, but normally is used to run like receipts, right? So a bunch of sequential commands in a line. It's well, make was normally used and is mostly used during, especially for Linux users, as a tool to build and compile applications. So back in the days when you don't have TARGZ and RPMs or even specific distributions of Linux that doesn't have any package manager, everything used to be compiled for that specific machine. And in that case, sorry guys, in that case, Makefile was mostly used because you had to run so many commands, and a Makefile would make easier for compiling and installing that package, right? So lots of people in the DevOps community starts to make use of make to run specific set of instructions just because it worked properly for building applications. Why not to run, for example, Docker build and specific with specific parameters that make a lot more easier using make than typing out the comments that you need, right? So make becomes very popular among DevOps community, especially the three of us. We use make on our daily basis with pretty much everything that we create. One of the biggest benefits is that it runs in multiple platforms and shells because it's kind of a language, like you can have if, else, for, and loops and everything, and it's multi-platform. So I can run the same make commands in my Linux, and then it will run the same make commands in his Mac OS. So it's going to be most of the time seamless, right? So that's one of the biggest benefit, that we run into multiple platforms in a similar way. The make command, it used the make file, again, another file, just like the Dockerfile, the Docker Compose file, but make file is where all the logic and other instructions for those receipts resides. And again, make will run against the make file in the folder that you are running from. So if you don't have a make file, you just complain that there is no make targets to run. An example of make file we have here in the make class, just a basic one. So as you can see, you can specify variables here, and this is the smallest piece of the make file. You normally have a target name, which in this case is say hello world, and the instructions that will be executed when that target is invoked. Right, so if you just say invoke the say hello world, we'll just execute this piece of code that resides here. Coming back here, yeah, these are the examples. Let me just run that here. It's probably easier and make things. basic. So if I just run, I'm just copy and paste just to make things easier and don't make mistake. So you normally invoke by the use of make command and the target, and you just execute the hello world there, right? So it's that simple, and that case might be really simple, and you might not see a very good use case for that. I'll just bring something extra later, and you can see that things are make sense to use make sometimes, right? But here, one of the things that we have on make is you can have, like here, you can have a target that will run multiple targets or run, let's say, pre the execution of this target here. I can say to execute these of the other target. So if I just run, let's first run this make create file here, and you guys gonna see it just create a file and list the file output.txt, which is what I'm saying here. The file is output because I have this environment variable here. And what that interrogation mark and equal says is, if I'm not defining this variable during the execution, just use this as a default. So if I just say file equals make read file. Now I just created the output 1, 2, 3. So you can pass variables that will be executed by the command, by the make, through the environment variables definition that you have here. All right. And if you try to run the write to file target with a make write to file, you first execute the create file and then you write something to the file. So if you just run, as you can see, create the file output.txt and then write something to the file. So if you just say get output.txt, it has writing to file inside it. So you can you can in your target, you can define prerequisite that needs to be run before it executes the instructions and the receipt that resides inside the target file. Target make target, sorry. Let me just make remove file here, make remove file. I'll just remove that file from here, which is the last step here. Multiple targets, which I covered. The prerequisites, which is fine, the variables as well. Let's jump into this other file here, which is probably will make a lot more sense to you guys. This is probably something that you guys will use, especially in the project itself. But yeah, you guys can figure out that later. But basically here I have some Docker targets. So I have a build, I can have a run, I have a publish, and I have a clean. And those targets will execute a bunch of commands here. So that's when make becomes useful, when you have to execute things like that. Instead of you requiring to execute something like those 4 or 6 lines, you can just make run and we'll just execute that for you. So especially when things start to get either you have multiple components or multiple environment variables or multiple parameters that you need to pass, make becomes great, brings a lot of benefits in that, because makes much easier to run things and speed up the process of building, deploying, testing, and things like that, right? So in that case, let me just change here to my registry, which is a Docker registry that I have. Image, let's use here da.image, save here. So what I'm defining here is just those environment variables that will be used through those other through those instructions, those targets here. I won't change those because it won't matter a lot. I'm also just using the test as a tag, but could be changed as well, and could be send through the execution itself. And then it's just Docker commands here, but basically here I'm building Docker based on this Dockerfile, which is the same Dockerfile from previous lab. Here I have running. I'm running the Docker with a Docker run, specifying import and with all the environment variables if required. Here I'm publishing the image, which is pushing the image from my local to Docker registry, in this case, Docker Hub, and I'll show you the image there. And then just a cleanup step just to make sure everything is cleaned up from my local, right? So if I run here in the Docker Hub, let me just jump into my, you can have your own Docker registry. You just create a new user account there and you can push public images easily. I have a few images here, but I don't have any, the DA, which is the name that I define here. DA web image I don't have here. As you can see, I just have a DA example. So what I run here in this Docker folder, let me just change, not Docker, make folder, basics, cd thing. So if I just run make build, we just build my image. So as you can see, things starts to be a lot easier when you have this, instead of just running all those commands. Just run make and make run, for example, and I'm forwarding now to port 8081. And oops. So if I just can localhost 8081, I'm running that my test, so it becomes just much easier to run things. If I want to run make publish, now this is just tagging my image to that name, and now it's just pushing the image to my Docker registry, which is in Docker Hub. It's pushing. As you can see, it also pushes layer, because Docker Hub also has this layer concept. So if it already has a layer there, it won't be pushed again. And yep, completed successfully. So if I just come back here and reload, I should have my new image there. Yep, the Docker image, web image, just pushed it a few seconds ago. It's public, so anyone can just pull that image and use if they want. But yeah, that's how make can be useful. And especially if you start to use with Docker Compose, which is not the case here, because you guys gonna have exercise on that in the future, and you guys gonna see that in action in the Three Musketeer class. But yeah, make is very, very useful in terms of making things easier and faster in order to execute some commands that instead of typing or even copying and paste, you just run two words and you can pretty much execute what you need. So that's one of the biggest benefits of make. Sorry for rushing that. I was trying to reach the 8:30 time, but if you guys have any questions, feel free.
I think not always there is a pattern in make files, or we need to follow this one.
There is no pattern. This is a Docker make file to run Docker commands. You're normally gonna see things similar: Docker build, Docker run, Docker publish. But it can be anything. You can even have one additional step here as a Docker build and publish. So that will just run both the build and the publish. So you can be as creative as you need, as long as it fulfills the requirements that you have. So there is no pattern. You can have any name here that you want. It's not because the command that I'm executing here is run. It needs to run. It needs to be called run. no, that's not the case. You can just change here to, instead of build, I'm just gonna change to Docker Gustavo here. It's not Docker, sorry, make it Gustavo. And if I just run make it Gustavo,
the target, you changed it to funny.
Sorry, yep. Gustavo, and now I'm building an image with the make Gustavo. So you can use whatever name you want. It's just that in some cases makes sense to use those run, build, publish, because it just makes sense. It reflects exactly what you're trying to achieve with that target.
Mm-hmm.
But you can use whatever name you want.
Yeah, in my team where I work, we have this convention. So we know for every service repo that we have, we'll find make build, make test, make linked, make security, make deploy, and make deploy API. So I don't need to keep searching in the make file to see which targets are available, but it's a convention that we got in my team. So it's opened, but it's good to have some kind of convention just for other people to get on board easily.
If
of course.
If it's a pattern on your company, then you know that every repository that you go, you just do make builds, and you know that it's gonna build yours, whatever you need to build, and push whatever you need to push.
Yeah, it could be, for example, push instead of publish, but again, it's you can choose. But if your company has some standards, just make use of that. And it's good because everyone will be using the same things. It makes sense.
Mm-hmm. That's fine. Thank
Do
you.
you guys use Make for AWS CLI as well, or just for Docker?
You can run for anything. So for example, in the previous classes, if you want to create a make class 1, exercise 1, make exercise 2, make exercise 2, you could.
You can show on the repository Kiko the script folder. We actually use make that pattern of make to build Terraform, to build the GitHub itself.
So yeah, you have here Docker Compose being used. We have the Git Terraform.
Need plan apply. So pretty much make apply just doing Terraform. You need Terraform plan, Terraform apply.
The dashboard that you guys receive on the Slack channels is run through this. So just run make dashboard. It generates all the charts, grabs all the informations and publish in the Slack. So you can execute anything you want here. It's not about Docker. It's not about AWS. It can be anything.
Yeah. You also have there just in the middle GH plan. That is the plan that the GitHub needs to run to get research created. It's for the automation. So you can see that the target itself, it's calling 2 other targets, the init and the plan in just one. So instead of having to go through all the commands by yourself, you just do one target and we'll go through all your dependencies.
Nice.
You can also do with Bash, right? Against the pattern. It's just ways of doing just patterns, approach. We highly recommend going through that way with the make and Docker Compose.
Mm-hmm. And one last thing, for this class, we have around 11 exercises.
Woohoo!
So it's similar to the previous class. So I recommend to get this going as soon as you can.
Absolutely.
Because this class is very important for the rest of the course. So I recommend doing all the exercises, trying all the exercises. Let us know if you need some help.
Yeah, there is only one that is still resides in this folder, which is the Docker 07. Because we used to have the ECR and ECS in the same class, I still kept that exercise, but you guys can skip this one because we're gonna have another class just about ECS and ECR. and we're probably gonna move this exercise or something similar to this new class. So you can just skip this C03 Docker 007 exercise.
It's marked as deprecated.
I consider the Docker content the most valuable thing that you guys can learn from this group, from this course.
The benefits of Docker on our daily job, for me at least, is yeah, it's.
I pretty much have nothing installed on my computer. It's everything with Docker and shortcuts to run from images, because it's so much easier and portable.
It's not just about the tool, because you just learned the tool, right? But it's the way you think about it. So let's suppose you want to compile an R is a language, right? Or a Ruby application or something like that. You don't need to install the tool. You can containerize the CLI or the compiler or whatever resource you need to make something run. So it's reusable for everybody, not only by you. So it's a difference when you're going to tackle a problem. Try and think if you can containerize this to make it more reusable as a development tool as well for your team.
Yeah, especially around the prerequisites and conflicts. So you might have, I don't know, different versions of Java, different versions of nodes installed. And if you're not using Docker, your application might use the wrong version when running something that it shouldn't. So in Docker, you make sure that only that specific version that you need and you know that will work is installed in that image, is part of that image. So you guarantee that anywhere that you run that code in that specific container, you'll be run exactly as you want to run. So it's, yeah, it brings a lot of benefits, lots of benefits.
Hey guys, just before finishing, I have just one thing that I forgot to mention from the first class. Let me say that before I forget. The load balancer, it's not free, so don't forget to delete that. It's not very expensive for the usage that you guys will have for the exercise. So if you forget about it, 30 days, it's gonna cost $15, $20, something like that. It's not much, but don't forget to delete after you run the exercise.
Hang on.
Mom, it's not.
All right.
Cool. Any other questions before we finish up for the night, guys?
No, I just want to thank you and thank you all, because Kyle's lesson and yours, Kiko, were pretty good with like hands-on. I really appreciate that.
Yeah, the future class should be more like this, Fernando. The first one was we can change the AWS VPC and to move into something like this. The previous one is kind of hard, but yeah, we'll see what we can do. But expect for Terraform and Three Musketeers and CI/CD, it'll be similar to those two classes that you had today.
Yeah, it was great. Thank you.
A quick heads up for the next class. We'll do a pilot on that. It's going to be a trial. So we invited some external speaker to give the first part of the class. So it's going to be two guys. They are solutions architects from AWS. They will be covering the ECS part, which is the container management solution on AWS. We hope that will be nice, like, so you guys are not tired of our voice. See some different people sharing knowledge as well. We'll see how it goes. If that works, we probably will we'll see if we can invite some other people as well.
Yeah. Hey guys, I just released the poll that we are having for every class. So 30 seconds if you can vote. We really appreciate that to improve the classes.
And you guys can also provide feedback through Slack if you guys maybe this pool doesn't provide all how you want to provide your feedback. just reach out to us, and yeah, just provide your feedback. We are more than happy to receive feedback and improve as we go. This is just the second time that we are running that. We already made some change to improve from the first one, but any feedback is welcome.
Yeah, for sure, Kiko.
Thank you for the credits too. Kayo, okay, Kayo had sent credits on the Slack
Oh,
channel.
yeah.
Everyone
Oh
got,
yeah, we got $20.
Yeah.
everyone got that working?
On the same day, boom. Yeah.
Yeah.
Nice.
That came from this partnership that we are trying to get with the guys from AWS. They are being really supportive on this project. It's nice.
Would be pretty helpful for that NAT gateway exercise. So
Yeah. Just don't forget to delete it because it's going to be more than $20 per month.
I also got one. I got email from AWS to do a survey, and they would give you like $25 credits. So I don't know if it was targeted just to newbies or to whoever create the account for the first time. But if you create the account for the DevOps Academy, definitely check. You might have like another $25 there just waiting.
Yeah, I also got this email because some AWS event. It's cool. Thanks, guys. I like this Makefile thing. This is like a pipeline to build the containers, but like I never ever seen it. It was very cool.
Yeah, if you want to have a read before the next class, Three Musketeers, threemusketeers.io. Have a read before coming to the next class.
Cool. It's just, yep, building everything together, but it's pretty nice.
Musketeers. Very good, very good.
All right.
Last one for tonight, sorry. We said on the first class, you guys are welcome to review others' PRs as well. You can start doing that if you, like you can approve, you still won't be able to merge because you won't have permission, but if you approve, it helps us to get, at least we know that someone already have a look, and then we will go just scan to the exercise. We really recommend you doing because it's an interesting processing of reviewing others people's job, and don't worry on being picky and making people to do it again, the exercise. We learn a lot doing that actually. Cool.
Okay.
Right.
Well, thanks a lot, guys.
Have a good night, everyone.
Thanks so much,
for
Kayo.
joining
Thanks, Kiko. Everyone else.
weeks.
Have a good night.
And reach out if you guys need any help.
Wash your hands after.
Take care.
Good night. Bye.
Good night. Bye-bye.
Good night. Bye.
Guys, yeah, bye.